So, hi, welcome back, and yeah, we are with the next topic, that is the AC voltage applied to an inductor. We already know what's the AC voltage and everything is done, and yeah, resistance. What just happened? I'm sorry about this. Okay, yeah. So the AC voltage applied to an inductor, will keep it very short and sweet. So before I explain, let me just read it once and then I'll continue it. Okay, I'm done with all of those, and the AC voltage applied to an inductor is my next aim to be cracked. So first of all, let me show you the whole derivation. Let me make it interesting, guys. First of all, let's draw a circuit which is representing the whole thing over here. A very neat one, okay? Yeah. So consider there is one pure inductor which is attached in a circuit of which is having a AC source. Okay, this is a AC source and this is a pure inductor which is attached. Okay, clear. So let this inductor be in the first chapter we already know this thing be L and this thing is a AC source. So here we get that the voltage over here will be the voltage, the alternating voltage will be given by, we know the value of that, it will be a V naught sine omega t will be the value of our alternating voltage. So what's our aim? Our aim is to basically find out the value of I in this derivation. To find out the value of current is our aim. So keeping that in our mind, we will work according to what we need it over here. We got it as the thing, this thing is already given. See, if you see it, right? This thing is already given over here. V naught sine omega t, we already know it, and this thing is already given. So, since this is an inducer, in the first chapter of this induced EMF and stuff, we might have already learned it before, okay? When we used a pure resistor over there, so it's common that we can be using a normal Ohm's law, but here the resistor isn't present, so definitely we can't be using the Ohm's law because arca role is completely absent over here. We won't be seeing that role itself. So there is something else. We will be finding some alternative way or some supplementary way for getting the value which we needed. Right? Okay, fine. So yes, alternating way, what do I see is that in this thing we see that here, since there is this song, L is there, right? Since there is this L over here, so obviously it is related to something getting induced over there. As the voltage changes, as the voltage continuously changes, we know that the current is gonna get induced or something. Okay, so obviously we also know the value of the induced current from the chapters before. The induced current will be equal to, so here we already know that the induced current will be equal to RE, that is our induced current will be equal to the change in the voltage, right? So it will be there's a formula, okay, it's a formula over here, minus L di by dt. So yeah, I would prefer you to just by heart it, guys. I'm sorry for saying this, but yeah, time is very less. By heart it. Yeah. Yeah, by heart it. So yes, what is the value? E is equal to minus L di by dt. Minus L di by dt. So yes, our E is equal to minus L di by dt. So E is equal to minus L di by dt. E is equal to minus L. A change in a voltage will help in the current getting induced. So we need the value of an induced current, right? So yes, we can get the value as our... So yes, after this, I surely know that all of you know about the Kirchhoff law, which we studied in the chapter of current and electricity. So there was something stated in the Kirchhoff law over here that, moving in the direction, we get it over here, something like that. So therefore, in the Kirchhoff law, we get that when it is when the velocity is somewhat moving in a circle, we learned something like the sum of everything will be equal to 0. That is what we learned in our Kirchhoff law, right? So yes, obviously, what did it state then? Kirchhoff's second law. I'm speaking about the second law of Kirchhoff's. So it stated that a V plus E is equal to 0. So obviously from this thing we are gonna get something special. Now we are just gonna put the value of that. V minus L di by dt is equal to 0. So therefore we can get it as a V is equal to L di by dt. Okay, great, going good. So now, as I already said, your aim is to find out the value of I. So you can just take it over here, shift, do like whatever you want, take it over there and shift. And by that, yeah, I mean, I am pretty sure that all of you know this basic maths, right? Yeah, I'm hoping that all of you know this basic maths. So therefore, I'm going to get it as, let me even put the value of V. It is going to be a V naught sine omega t by L dt, and here will be our di ka value. Okay, and here will be our di ka value. Fine, good. So that is what we are getting. Right, so to remove this di, we have to be doing something special for sure. Something special for sure, right? Wait, first let me just draw a border line over here so that I don't cross this thing. Yeah. So we'll do the remaining stuff from this side. This is what we got. So now, keep an aim of integrating this thing. Di will be equal to integrate this whole thing also. Yeah, integrate this thing also, where you're gonna just remove your V naught by L outside it. Right, because wait. V naught by L will just go outside, then integrate whole thing that is inside because it's a function of t. So omega t by and dt. So yeah, while integrating, we already know maths. I think that you all are familiar with the maths stuff. Okay, so you are gonna get it as a V naught by L sine omega t ka integration would be a minus cos omega t. Okay, minus just disappeared over there somewhere. Minus cos omega t by omega. That's the value, guys. For that, you obviously need to know maths. Don't by heart this. I'm saying you don't by heart this. So which will be equal to c. And c, we already know that c is a constant over here. So we can just we can ignore it actually. But the average value of cos omega t and I over one complete cycle is 0. The average value of cos omega t and I over one complete cycle, okay, over one complete cycle, when we take all of these like average, it is equal to 0 when we consider this AC ka thing. So obviously we'll consider it to be 0. So therefore the final thing, what is a final thing that we can conclude it with? What's the final thing that we get? We can get it as a V naught by omega L, yes, V naught by omega L. So now guys, now the special thing is that if you look carefully, right, see, this thing is in a form of sine omega t. So it's obviously our responsibility. It's not like a responsibility, and it's impossible that we write one thing in a form of like sine omega t ka form and one thing in a form of cos omega t ka form. That's not possible, guys. So now it's our duty to find out something which is very useful. We get a proper one over here, right? So yes, what do we need to get? Maths obviously, man. I removed the cos, this thing out, and how do I convert it into sine? Minus cos is removing out, just exclude that minus 1. So now my aim is that how do I get sine over here? So how can I write sine over here? Okay, how this thing can be written in a form of sine. That's my responsibility, and that's my aim now. What is to be done is my aim to be found out. So it goes on like our I'm sorry for the color. So this thing can also be written as a sine u by so sine omega t, right? Sine omega t, we can also write it as no, not sine omega t. What am I doing? See, 90 minus any theta angle will be equal to cos theta, which we already know, right? Yeah, which we already know. Will be equal to our cos theta. So it will go on like a sine ka will be equal to cos theta, and this minus, why did I leave it, man? Okay, yeah, this was already there in cos, so I just wrote it outside. So now you take this minus inside, and this is a normal one where you're getting a proper cos theta ka value. So now if you observe this, right, let me again change it. If you observe this properly, this value, I mean, just exclude this minus thing outside, okay? I'm not saying you to include this. This value will be equal to this value. I mean, remove this thing out, this is not even included over here. This value will be equal to the value of this thing. You know maths for sure, man. Being in 12th, at least so much you people need to know, and yeah, I know that you know it. So then take this minus inside. So what is the thing which you're gonna get it again? No, it's okay, the final answer, right? By, omega L. This thing will just go inside. So final answer that we're gonna get will be a omega t minus pi by 2. These are the derivation where there's a chances of these things coming to your exam, and that's the only reason I'm explaining it to you, okay? But actually, if you see, this derivation is not necessarily required because we have to only know the concept over here. So guys, successfully we are here with the final results. We can take this value, see there, when we learned the before one, it was like V naught by R when we learned about the resistance and we got a value over there. Here we can consider this whole value to be like that, okay? Yeah, so it will be like a sine omega, this thing where our omega t minus pi by 2, this is a normal value which we are going to get for our I naught ka value. And one thing you must be able to observe here is that this thing, when you compare this and this thing, it's so much clearly visible that there is a minus sign over here, okay? There is a minus sign over here. There's a minus sign over here. Due to this, you can clearly understand that the current is lagged behind the voltage, right? So we can even draw a graph based on this. Let me draw it again. Let me draw it soon. Okay, we can even draw a graph based on this where there is a difference. So clearly our I is lagging the voltage, okay? Our current is lagging the voltage, and yeah. So therefore, what can we conclude it with, guys? We can conclude it saying that the thing whichever, when a pure inductor is connected to a AC current, to a AC, whatever AC source, when a pure inductor is connected to a AC source, then the current is lagging the voltage. Okay, current lags behind the voltage, but when it is a pure resistor source, we can say that the current and the voltage, there is no phase difference at all. They are at the same direction, whereas this thing just lags that thing do not have any same direction. Okay, it's the same. And then the final one the last one that will be this, when a pure capacitor is connected to that. For that thing, guys, this thing took like 15 minutes for me. I mean, it's not I don't like recommend this thing, okay, because we need to complete it before 15 minutes already. The next one did not have like many previous year questions has not come, so I wouldn't derive it, but I would obviously of course say you the explanation, okay, how does that work. That's all, and they will end this part, guys. Thank you for attending. I hope everything was good, you have understood everything. No, wait, before that I even forgot to draw the graph. Let me make it neat again. This is our x-axis, this is our y-axis, this is our x-axis. So yeah, let me represent the two things, white and pink. Let me somewhat use the contrasting colors over here. So this thing, guys, it represents what? It represents the velocity, whereas our current is lagging by pi by 2. Yes, this represents the current. In a pure inductor, the current lags the voltage, and yes, angle, we need to know the angle also. Angle here will be a omega t, but this thing lags from our this thing by the value of pi by 2. This thing is our I naught and I naught, and this thing will be my V naught. And yes, surely finally I'm getting the value, and this is a graph for it. Okay, MCQ question will be asked. So yes, I mean, why to be scared of the MCQ value when you know the whole concept over here. Congratulations, guys, you're thorough with it, and thank you so much, and bye-bye. Okay, bye-bye. It's correct 15 minutes or something. I hope the concepts are clear.